We will look at Chapter 3, Probability, Unit 1, Chapter 3, Section 3.3, solve a contextual problem that involves permutations or combinations and probability. In this lesson, we will learn using how to use counting methods from Chapter 2 to determine the probability of events. If we recall that probability is the ratio of favorable outcomes to the total number of outcomes possible, odds in favor is the ratio of the number of favorable outcomes to the number of unfavorable outcomes. Odds against the ratio of unfavorable outcomes to the number of favorable outcomes. If we go back and look at combinations and permutations from Chapter 2, we see that combinations are where order is not important. So we have N choose R, or it could be written N choose R is equal to N factorial over R factorial multiplied by N subtract R factorial, where R is greater than or equal to 0, but less than or equal to N. Permutations, on the other hand, where order is important, is N permute R, which equals N factorial over N subtract R factorial. And once again, R is greater than or equal to 0, but less than or equal to N. These two formulas, the combination formula and the permutation formula, will be given to us on our formula sheet. Let's look at an example. We have 4 boys and 5 girls are signed up for a leadership conference, yet only 3 students can go to the conference. What is the probability that only boys will go to the conference? This question sounds like a question that would be asked in Chapter 2 about determining the number of different ways the students can go to the conference, or the number of different ways we can choose the students to go to the conference. What makes it different is that we ask what is the probability that only boys will go to the conference. So we find the probability of only boys. Of course, on top we have the favorable outcomes. We only want boys, and what's on top in the numerator will be only boys. And we have 3 students going to the conference and 4 boys to choose from. So we have 4 choose 3. In the denominator, the number of total possible outcomes, there are 3 positions, yet there are 9 people in total. That is the 4 boys and the 5 girls, 9 people in total to choose from to fill the 3 positions. When we calculate 4 choose 3 over 9 choose 3, we have 1 over 21. 1 over 21, or 0.0476, which is about 4.8%. Let's have a look at another example. Sorry, it's the same example, yet just a different scenario. 4 boys and 5 girls are signed up for the leadership conference, yet only 3 students can attend. What is the probability that there will be more girls than boys going to the conference? So we have different cases to satisfy this condition, that there will be more girls than boys. So we can have 2 girls and 1 boy, or we can have 3 girls. So the probability that there will be more girls, we have to take each one of the individual cases and add them. Since there's an or, we use addition. So for the first case, we have 4 boys to choose from, going in one position, and 5 girls to choose from, going in 2 positions. This will give us, then in the second case, we have 4 boys to choose from in 0 positions, and this should be 5 girls to choose from. 5 girls to choose from to go in 3 positions. Once again, this is what we want over the total. The total remains the same since there are still 3 positions to fill and 9 people to choose from. The answer to this one would not be 10 over 21. It would be 25 over 42, which would be 0.595, or about 60%. Joey and Katie are in line with 4 other people. What is the probability that Joey and Katie are standing next to each other? Once again, it looks like a problem where we're asking how many different arrangements can there be if Joey and Katie are to stand together. It's similar to a question from Chapter 2, yet it's asking us the probability. So let's find the total number of ways. We have 6 people to choose from, and in the first position, there will be 6 people to go in the first position, 5 people to go in the second position, 4 people to go in the third, 3, 2, and 1. This is the total number of ways, which is 720. Now, if Joey and Katie are standing in line, Joey could be here, which means Katie could be here. That leaves 4 options for here, 3, 2, 1. Yet, Katie could be here, and Joey could be in this position. That means there are 2 options for here, leaving 1 for here. That equals 48. Different possibilities if Joey and Katie are in the first and second position. If Joey and Katie are in the second and third position, so we have Joey and Katie, or it could be Katie and Joey, we still have 3, 2, and 1. Once again, there's 2 positions here, leaving 1 position here, leaving 1 option for here rather, giving us a total of 48. This can happen again, putting Joey and Katie in the third and fourth position, still giving us 48. Or Joey and Katie could be in the fourth and fifth position, or Katie and Joey. And of course the last position, the fifth and the sixth position, Joey and Katie. Giving us a total of 240 options for Joey and Katie to be standing next to each other in line. The probability would be 240 over the total number of ways, 720, which equals, of course, 1/3, or 33%. If a 4-digit number is generated at random from the digits 2, 3, 5, and 7 without repetition, what is the probability that the number will be even? Let's first have a look at the total number of ways. The digit that can go in the first position, of course there are 4 digits in total, so there are 4 options for the first digit, 3 options for the second, 2, and then 1, giving us a total of 24 different 4-digit numbers. Yet the number of ways that can be even, the number 2 must go in the last position in order for this number to be even. So there's only one option for the last position, leaving 3 numbers for the first, 2, and 1, giving us a total of 6 options to have an even number. When we're looking at the probability of an even number will be what we want over the total number of possible outcomes. What we want, there's 6 options over a total of 24, giving us 1/4, or 25%. When considering the possible arrangements of the letters in the word champ, what is the probability of the letters C and H being together? Very similar to the Joey-Katie question, you may want to pause the clip and attempt this question on your own. I will continue with the solution. The total number of ways these letters could be arranged, of course, is 5 factorial. 5 times 4 times 3 times 2 times 1, which equals 120. Okay, so we have C and H could go here. That means, or it could be H and C. So there's 2 options for the first, 1 for the second, then leaving us with 3, 2, 1, giving us 12 options. Yet this could do this for the second. C and H could be in the second and third position, which is another 12. It could be in the third and fourth position, which would be 12 again, or the fourth and fifth position, which would be 12, giving us a total of 48. We have 48, which is the options that we want, the ones that are favorable to us, over 120, which is the total number of possibilities. This being 2 over 5, or 2/5, which is 0.4, or 40%. In summary, we have to recall that probability of event A is the number of outcomes favorable to A, what we want, over the total number of outcomes possible. Some of these problems that use counting methods are similar to the counting problems in Chapter 2, but you have to recall that they are asking for the probability. So just finding the outcomes favorable to A is not enough. We have to divide it by the total.